So the question number 3 says that show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. Now this is again the same question just like the question number 1 and 2. So let's just start the solution set of this particular question. First of all, the key points over here are we have to form either the number of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So the very important or the thing that is common in between these three numbers is that there is a use of a number 6. It means that we have to take the number b as 6. So let's just start with it. Let a be any positive, let a be any positive integer, let a be any positive integer and b is equal to 6. So I'm taking b as 6 over here. Let us suppose I'm calling it as star. So by Euclid's division lemma, we know that a is equal to bq plus of r with the condition that r is always lying in between 0 and b. So we are using the Euclid's division lemma over here. So let us suppose I'm putting it under a table, in a box, sorry. Let's just substitute the value of b is equal to 6, that is star, in this particular equation. So it will be like a is equal to b. What is the value of b? b is nothing but 6. So it is 6q plus of r with a condition over here that the value of r will lie in between 0 and 6. Now the again condition will be like, the value of r can be 0. Let us suppose I'm writing it over here. The value of r can be 0, 1, 2, 3, 4, 5, but it cannot be 6 because there is no such equality over here. So the values of r can be these three, 1, 2, 3, 4, 5, 6, these 6 numbers. So we have to form the 6 cases over here again, but we just wanted to find out the positive odd integer only. So whenever we will get any even integer out of any particular case, then we will definitely neglect it because we just wanted to find out the positive odd integer only. So let's just start the case number 1. So let us suppose I'm talking about the case number 1 in which I am taking remainder, that is r is equal to 0. Substitute the value of r is equal to 0 in the equation. So let us suppose I'm calling this equation as equation number 1. So we are substituting r is equal to 0 in the equation number 1. So substitute the value. A is nothing but 6q plus of 0. So it means that it is nothing but 6q. We can write it in the formation as 2 into 3q, and we know that whenever 2 is a factor of any particular number, then that number is definitely an even integer. So it means that this is a case of getting an even number. So this case would definitely be neglected because we just wanted to find out the number that are odd numbers. So it means that case number 1 is neglected. Let's just move on to the case number 2. The case number 2 will be like the value of remainder is nothing but 1. Substitute the value of r is equal to 1 in the equation number 1. So a is nothing but 6q plus remainder is nothing but 1. And we know that 6q is an even integer. Even plus 1 is nothing but an odd integer. It means that a is equal to 6q plus 1 is an odd integer. So let us suppose I'm writing integer as int. So this is our very first answer because we just wanted to show that the odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So the very first answer is that the odd integer is of the type 6q plus 1. Now we are done with the very first formation, that is 6q plus 1. Now we have proved that either it is of the form 6q plus 3 or either it is of the form 6q plus 5. So let's just move on further toward the case number 3. So if I'm drawing a line in between these two cases. So case number 3 will be like remainder is 2, substitute r is equal to 2, over here. So a is equal to 6q plus of 2. We can take 2 as common value from here. So we get the answer as 3q plus of 1. Obviously, this number do have a factor as 2. It means that it is nothing but an even integer. So we have to neglect this case again. It is neglected. Why so? Because we just wanted to find out an odd integer rather than finding out an even integer. So this case is totally neglected. So let's just move on further toward the case number 4. So the case number 4 will be like remainder is equal to 3. When we will substitute remainder as r is equal to 3, then we get the answer as a is equal to 6q plus of 3. Again, we do know that 6q is nothing but an even integer. So let us suppose I'm writing it as e, and 3 is nothing but an odd integer. So whenever we will add even and an odd integer, we get the answer as an odd integer. So obviously it results into an odd integer. It is nothing but an odd integer. So this is an odd integer. So a is equal to 6q plus 3 is an odd integer. So our second formation is all clear, because we just wanted to prove either it is of the form 6q plus 1. So this is our first case. Either it is of the form 6q plus 3. So this is our second case. Let's just move on further toward the next case. And the next case is case number 5. Case number 5, in which the remainder r is nothing but 4. Substitute r is equal to 4. A will be 6q plus of 4 type. We can take the 2 as common over here. So it will be of the form 3q plus of 2. Again, we know that 2 is a factor of this particular number. So this is nothing but an even integer. So hence this case is again neglected, because we just do not want to find out the case of an even integer. We are taking the case of an odd integer only. So let's just move on toward the case number 6, in which the remainder is nothing but 5. Substitute the value of r as 5. So a is equal to 6q plus of 5. Again, we can say that this is nothing but an even integer. This is nothing but an odd integer, and an addition of even and odd is nothing but an odd. So this is nothing but an odd integer. This is nothing but an odd integer. So a is equal to 6q plus 5 is an odd integer. So the three cases are all clear to you, I guess, that a is either of the form 6q plus 1, which is an odd integer. A is either of the form 6q plus 3, or either it is of the form 6q plus 5. So our question says show that any positive odd integer is either of the form 6q plus 1, 6q plus 3 and 6q plus 5. So this is nothing but the solution set of this particular question. I hope all the cases are all clear to you, that why we have neglected these cases for the even ones, and why we have taken the cases for the odd integer, because we just wanted to find out the case of an odd integer only. So let's just move on further and talk about another interesting question.